So another way of modeling how electrons fill up energy levels and energy sublevels is using orbital diagrams. And so orbital diagrams follow the same rules as we do when we're doing electron configurations, and that's that electrons will occupy the lowest energy level and orbital first, that only 2 electrons can fit in an orbital, and that each electron has opposite spin, and that every orbital in a sublevel must have 1 electron before any of the orbitals will get a second electron. And so let's just recall that we have 4 types of orbitals, S, P, D, and F. And the S's come in sets of 1, P's come in sets of 3, D's come in sets of 5, and F's come in sets of 7. So the maximum number of electrons that can go in an S is 2, the maximum number in a P is 6, in a D is 10, and in F, the maximum number is 14. So we're going to look at an example using arsenic, and we're going to look at its orbital diagram. So we're going to start off with the 1s, because it's the lowest energy level and sublevel available. We're going to put 1 electron here in it, and then we're going to put a second electron in there. Then we'll go to the second energy level, which is 2, and sublevel, which is S. We're going to put 1, 2 in. Now, just as a reminder, arsenic has 33 electrons. So then we go to our 2p, and we're going to put 1 electron in each of these 3 orbitals before we start to double up. And then we'll go to our 3s, which is the next energy level and sublevel. We're going to put 1 electron in, then the second electron in. Then we can go to the 3p, and we can put 1 electron in each of the p orbitals before we double up. And then we can put a second one in. So now we will go to our 4s, put 1 electron in each spot, and now it's full. We have 1 up spin and 1 down spin. And then we go to our 3d, and this one has 5 orbitals, so we can put 1 electron in each before we start to double up. And then finally we go to our 4p. Up to this point we've used up 30 electrons. We've got 3 left. So we put in 1 electron in each of the p orbitals, and now we have 33 electrons, and this is arsenic's orbital diagram. So now I'm going to take you on to an example where I'm going to model it using the height of the energy levels and sublevels to kind of show you how orbital diagrams can be visualized. So when we fill up orbitals, remember our rules are that we can put 1 electron in at a time. And then after we put the first electron in, we can put in the second one here in this 1s. We're going to go from the lowest energy level to the next energy level. So then we can go to the 2s, and we put 1 electron in there, and then we can put the second electron. If we have more electrons, now with these 2p's, we have to put 1 electron in each of the p orbitals before we can double up. So after we put 1 in each, then we can start to double up. Then we can go to the 3s, put 1 in there, and we can double up. We can go to the p, put 1 in there, 1 in the next one, the next one, and then after that has electrons, then you can double up. So far we have 18 electrons here. So let's try to do an orbital diagram for iron. So iron, if we look it up on the periodic table, you have Fe, and it's got 26 protons, so we're going to have 26 electrons. So we've already got 18. We can continue to put 19, 20, and the 4s is full. And then we're going to go to the 3d. And so we've got 20. We're going to do 21, 22, 23, 24, 25, 26. And you'll see that some are left unfilled and some are filled, and that's iron's orbital diagram.